Are you bored and hot? Were you planning the best summer ever, but now you have nothing to do? Introducing the Water Blaster 3000. Good for all ages, the Water Blaster 3000 ensures that you will have fun with anyone at any time. Here we have a water gun fight. To the average human eye, it looks like kids just having fun, but we're not average. We're Laurelton Hall students. If you take a closer look, you will notice that it takes a lot more than fun to allow this water gun fight to work out. Confused? Take it away, Dr. Joyce.
Our water blaster, it uses three main concepts: pressure, energy, work, and power, and velocity. Pressure is very important in our water blaster because pressure is defined as a force per unit area. So when the blaster is pulled out in blasting mode and the water is in the barrel, it is pushed out with pressure, and that causes a stream of water. You can solve for pressure using pressure equals force divided by area, and in order to find the force, you need to get F equals ma, and to find the acceleration, you need to use delta V over delta t. Second concept for our water blaster is energy, work, and power. The power is defined as the rate at which work is done, and the water blaster's power is determined by how fast the blaster is blasted. The faster it is blasted, the more power behind the water there is, and the slower it is blasted, the less power behind the water there is. Work is defined as a force over a distance. So when a person applies a force on the end of the blaster to the front of the blaster, it causes the work, in which turn transfers into energy, and energy is defined as the capacity for doing work. Energy exists in many forms, such as potential, kinetic, thermal, and electrical, but the blaster specifically uses kinetic energy. Kinetic energy is the energy of an object that it possesses due to motion, and it is defined as the work needed to accelerate a body for a given mass from rest to its stated velocity. The blaster has kinetic energy while it is in a blasting mode specifically. To find energy, work, and power, you use all of these concepts. So power equals work over time, and that equals the force times the distance divided by time, which equals the FV. Work equals FD, and kinetic energy equals 1/2 times mv squared, and force equals ma, and to find velocity, you do distance over time. Our third concept for our water blaster is velocity. Velocity is defined as a measure of how fast something moves in a direction. The velocity of the water coming from the blaster is determined by the amount of time the water takes to travel a certain distance. So if the water is coming from the blaster slowly, it will have a slower velocity, but if the water is coming from the blaster quickly, it will have a faster velocity. To find velocity, you need the distance over the time. All of our physics concepts can be put into real-world applications. For example, the inflation of a tire is pressure because the pressure of air is what inflates the tire. A rubber band being zinged, in other words, is kinetic energy because the rubber band, when it is in motion, is a mass in motion. Walking upstairs is work because you need to work to go up the stairs. And the acceleration of a car is power because the car uses the power of the fuel to accelerate forward. And velocity is driving a car because the car is going a distance over an amount of time.
So I did our calculations. So first let's look at the data. So our mass is 1.408 kilograms. Our height of the water is 1.38 meters. Our distance of the water is 4.97 meters. And our time for the first drop of water to hit the ground is 1.36 seconds. And keep in mind that all of our data and calculations is in relation to that first drop of water. Then we have our FA is 8.0 newtons, and our VF we know is 0 meters per second. So first, what we had to do is calculate our average velocity, which is d over t. So we did V average is 4.97 over 1.37, and we got our average velocity is 3.6 meters per second. And then we use that to plug into the equation V average equals VF plus VI over 2. And if we do that out, then we get our VI is 7.3 meters per second. And then from there, we can calculate our acceleration of the water, which is A equals VF minus VI over T. So we do A equals 0 minus 7.254 over 1.36. And then you get negative 5.3 meters per second squared. And then if we go over here to part 3, we have enough information to find our potential energy. So you use the equation PE equals mgh to do PEG equals 1.408 times negative 9.8 times 1.38, and you get our potential gravitational energy is 19 joules.